Okay. Similarly, you will get as equal to as xy, then ds equal to del s by del x dx plus uh, del s by del y dy. And similarly for v, this will be v, this will be v volume. Here y means when you differentiate with respect to x, then y should be constant. Similarly, when you differentiate with respect to y, then x should be constant. Now you will get du and ds and dv. Then put this value, put this into equation. Uh, du equal to TDS minus P dV. Just du we got du, ds and dv. Just put this value du1 del u del x dx plus del u del y x dy equal to t ds. ds means del s del x y dx plus del s del y dy minus p dv del v del x y dx plus del v del y x dy. Now simplifying this equation, you will see my presentation, slide presentation. Just simplifying this equation and separate dx and dy, separate dx and dy separate, and finally the left hand side and right hand side. From the left hand side and the right hand side, you will collect the coefficient of dx. This is the coefficient of dx. dx এর সহগ, dx এর সহগ. This is the coefficient of dx and this is the coefficient of dy. Now you separate the dx and dy, then you will get also the coefficient of dx and coefficient of dy. Then the left hand side and right hand side, since the left hand side and right hand side equal, then the coefficient of dx, the coefficient of dx of left hand side and the coefficient of dx right hand side. This is the coefficient of dx of left hand side and this is the coefficient of dx of right hand side. This will be same. And similarly This is the coefficient of dy. This is the coefficient of dy, and this is the coefficient of dx. These are same. This will be same. Now you will see here the constant for this equation. The constant is y, and in this equation the constant is x. You only differentiate with respect to x here, as only differentiate with respect to x, as respect to x, v respect to x only. Here you differentiate with respect to y, as y, v, y. That means this equation differentiated by only with respect to x, y constant, and here with respect to y, x constant. But this u also depends on y. For this reason, we have to differentiate this equation with respect to y, and this equation with respect to x. Now if we differentiate this equation with respect to y, that is del by del y, del u by del x. The left hand side this is, and the right hand side del t by del y x, then del s by del x y plus t into del square s by del y del x. Similarly, this is the left hand side, okay, and this is for only for this one. Similarly, minus for this one you will differentiate, and you will see in my slide presentation this differentiation. And finally d square u del y del x equal to d square u del x del y. Actually, the left hand side of these two equations is same. Therefore we can write this one equal to this one. That means the previous two equations will be same. And this equation equal to this equation. And simplifying these two equations, you will get final most important equation, del t by del y x, del s del x, del s by del x y minus del y del t del y x del t del x y equal to del t del x y del s del y x minus del p del x y and del b del y x. From my slide presentation you will get this equation, and this is the parent equation uh, uh, from which Maxwell's relation will be found. Actually, there are 5, 6 Maxwell's relations, and we will get this Maxwell's relation from these parent equations. Just but here we only need the Maxwell's first relation. For first relation, x here x y x y x y. For first relation, x should be temperature T and y should be volume V. Now just put the T and V instead of x and y. Instead of x you have to put T, and instead of y you have to put V, volume. Just put this V and T, T and V, just V and T, X, T and V, X, T, Y, V, just V and T, X, T and V, V and T. Okay, now at this equation, concern about this term, this is temperature is differentiated with respect to volume. So temperature and volume, this should be variable, but here T means T constant. If T constant, then you cannot you could not differentiate T, so this will be 0. This will be 0. This is T constant. T is not variable, T is constant. Here T denoted as a constant, so you cannot differentiate T. If you differentiate a constant, then this should be 0. So this is 0. It's okay. This okay, and this also 0. So this is 0 means this one 0 minus this is 0, this one 0. The left hand side will be 0. The left hand side will be 0. The left hand side will be 0. So this is 0. Now del T by del T, this is 1, and del V by del T, this is 1. So you only found these two terms equal to 0. Therefore, you can write del S by del V T equal to del P by del T V. this is the first relation of Maxwell's first relation. Maxwell's first relation. uh, this equation implies that the increase of entropy per unit increase of volume, the increase of entropy, S means entropy, the del S means entropy, the increase of entropy per unit increase of volume at constant temperature is equal to the increase of pressure per unit increase of temperature in an isospheric process. Constant volume means isospheric process. So this is our required equation for required first relation of Maxwell's first relation. Now we will discuss about the third law of thermodynamics. Third law of thermodynamics. Then what is third law? The third law states that entropy of a system third law of thermodynamics. It states that the entropy of a system at absolute zero is a well-defined constant, and this constant is zero. Okay. Absolute zero means minus 273 degrees Celsius. This is called absolute zero temperature. Absolute zero temperature. At absolute zero temperature, there is no heat energy. If there is no heat energy, the entropy of a system will also be zero. If there is no heat energy, then the entropy, the disorderness, will also be zero. And this zero is a constant. Entropy of a system at absolute zero is well-defined constant. So entropy is a constant, and this constant is zero. Because absolute zero temperature, minus 273 degrees Celsius temperature, a system has no heat energy. Therefore, if it has no heat energy, the entropy means disorder, will also be zero, and this zero is a constant. This is the third law of thermodynamics. But the third law of thermodynamics, we actually we cannot achieve. We cannot this is not actually physically possible. This is not physically possible because no object or system can have a temperature of 0 Kelvin. Absolute zero temperature means 0 Kelvin. Minus 273 degrees Celsius means absolute zero, means 0 Kelvin. No object can have this temperature. Because a system, if a process absolute zero, if system, if a system a process at 2 absolute zero, it will eventually have to draw energy from whatever systems are nearby. That means if we decrease the temperature of a system, if we decrease the temperature of a system to absolute zero, then the system will collect heat energy from its surrounding. Therefore, we cannot reach the temperature at absolute 0 degrees Celsius of a system. So the system never obtain absolute zero. For this reason, this statement, this state is not physically possible, but it is a mathematical limit of the universe. Okay, today see you next class. Please print the slides of my presentation and then follow this video class collect from YouTube. Then my printed slides and this video both together will help to understand the physics. Thank you.